So what you're looking at here is what's called an NPV profile for both Project S and L. So the if we start out here at 0, we can see that the actual cash flows are greater for L than they are for Project S. And at a low required rate of return, Project L is actually worth more than Project S, the net present value. That's because the lower required rate of return places less value on those higher initial cash flows. So when we get to 10%, we see the numbers that we calculated previously. And if we go up to 15%, we see that both projects are negative. So the required rate of return is going to determine whether we accept or reject the projects. And it's also going to determine which projects we accept or reject. So we'll look at the NPV, look at these graphically on the next page. So we have our NPVs on the y-axis. And then the IRR on the x-axis. So at 8.1%, both projects have the exact same NPV. So looks like it's around $268. So, but any point below 8.1%, we would accept if our required rate of return were below 8.1%, we would accept Project L. Above the 8.1%, as long as the NPV is greater than 0, we're going to accept Project S. Two different reasons for NPV profiles to cross. One is scale differences. Smaller project frees up funds at some point for investment. The higher opportunity costs, the more valuable these funds are. Thus, our higher are going to favor smaller projects. The more likely issue is timing differences, which is what we saw with our two projects. Projects with faster payback provides cash flow more in early years for reinvestment. So the higher that required rate of return, the more likely they are to be valuable. Reinvestment rate assumptions. So NPV assumes that reinvestment at the required rate of return or the firm's cost, firm's cost of capital in most cases. The IRR assumes reinvestment at the internal rate of return. This may not necessarily be achievable. Reinvestment at the opportunity cost or required rate of return is more realistic. So NPV method is superior. The NPV should always be used to choose between mutually exclusive projects and ensures that the value is maximized. Multiple IRRs. So this is probably as great of argument for not using the internal rate of return as any. If a project has more than one negative cash flow, so it's going to have multiple internal rates of return. So for every negative cash flow on a project, it's going to have an additional internal rate of return. So for example, if a project had 3 negative cash flows, it would have 3 IRRs. 4, it would have 4 IRRs. So which one of those IRRs do you choose from? So we'll talk in the next lecture about modified internal rate of return. But in this case, the NPV profile for this project. So at 25%, the NPV is equal to 0, but also at 400%, the NPV is equal to 0. So We will talk about, again, as I mentioned, the modified internal rate of return in the next lecture, which will is a solution that alleviates this problem.